Hey everyone, thanks for your time. NASA and its Artemis partners don't seem as quiet the last few months and weeks, but is it busier now, or is it that we're getting more information about how busy it is? In this video, I'll go over the scenes that we saw this past week at the Kennedy Space Center, which is both a launch site and an assembly/production site. Now that more Orion and SLS hardware for the next 3 Artemis missions is at KSC, NASA's prime contractors are prepping that hardware for the next production milestones. The uncertainty about the Artemis II and Artemis III schedule remains, and we're still waiting for the consequential decision about the Orion heat shield. But Exploration Ground Systems is still positioned to support the Artemis II schedule, whatever it may turn out to be. I have more from a recent interview about that. Elsewhere, SpaceX's stance on the environment around their private Texas launch site for Starship is again in the news. The question for Artemis is how much will that affect NASA's exploration plans and schedules? SpaceX continues to wrestle with the impact that its rapidly expanding launch site on the Mexico border has with the surrounding environment. While the company pours resources into technical development and facility construction, they fell behind on their regulatory compliance. We found out how far behind this past week. The next Starship flight test might not be until Thanksgiving. I'll recap the Starship schedule uncertainty with the environment now possibly playing a bigger role. But first, let's go past the headlines and into the details about the next steps for the new Artemis hardware at KSC. After the delivery of SLS flight hardware to the Kennedy Space Center at the beginning of September, NASA provided some additional imagery and a little bit of context about their current status this past week. The launch vehicle stage adapter for the Artemis II SLS was dropped off in High Bay 4 of the Vehicle Assembly Building, and the engine section for Core Stage 4 and Artemis IV was parked in the VAB transfer aisle. Some additional imagery was taken on Monday, September 9th. In this B-roll video released, we can see that the Core Stage 4 engine section is wrapped up in its packaging on the south end of the transfer aisle, and you can see where it is relative to the fully completed Core Stage 2. Both articles are being kept air-conditioned with portable units to protect against corrosion, since the gigantic VAB doesn't have full air conditioning. The long-term Artemis schedule is still a big question mark, so we can't see the finish line, but Boeing tells me that the Core Stage 4 engine section will move to its integration and outfitting work site at the Space Systems Processing Facility in 2 to 3 weeks. The LVSA is also in storage, and it's pretty much in the same situation as the rest of the Artemis II SLS flight hardware. It is more or less ready to stack when its turn in the sequence comes. When that will be, though, is still uncertain, and we're waiting on big decisions from NASA leadership to get a better idea about that. NASA Kennedy Space Center Public Affairs also released imagery taken September 10th of the Core Stage 3 engine section and bow tail in the SSPF. Aside from a narrow field of view shot released earlier in 2024, these are the first glimpses of the Core Stage 3 engine section in 15 months. One of the images noted that the quadpods we see here were installed on September 10th, and both the visual and the information are indications that mating the bow tail to the engine section should happen soon. The quadpods are needed to support the engine section structure after the bow tail is attached, since the latter is not weight-bearing structure. We can see that many panels of cork have been attached to the outside of the engine section barrel over the last year and a half in the SSPF, but of course we can't see inside the barrel, which is where the critical work is. Boeing was working towards installation of some of the big main propulsion system elements inside: the 4 thrust vector control platforms and the 5 large composite overwrapped helium bottles that provide pneumatic pressure and purges for the MPS and the RS-25 engines that one day will be attached in the VAB. The last very high-level forecast was for completion of the whole core stage for Artemis III in 2025, which means by the end of 2025, which is only 15 months from now. In order to support that, realistically, the engine section and bow tail would need to be finished with standalone integration and standalone integrated testing in the SSPF by a year from now. There's not enough detail or evidence to tell whether that's realistic or not, though. The pictures in the SSPF show that work stands around the core stage 3 engine section have been moved away for installation of the quad pods and eventually the boat tail mate. Given that there are other customers in the SSPF, like Sierra Space processing their Dream Chaser hardware and Northrop Grumman processing their Cygnus spacecraft, the facility is now decently subscribed, and it may be that the Core Stage 4 engine section was parked in the VAB for a few weeks so that the Core Stage 3 hardware could be mated and repositioned. This is a shot of a map of the SSPF floor that I took on the SSPF floor way back in December 2015. Back then there was excess shuttle and space station hardware being stored there, but now we're seeing critical SLS production moving in. Boeing SLS engine section work in the SSPF is in the adjacent footprints 5 and 7 as seen on this map. Boeing said that the Core Stage 4 engine section will eventually be moved to footprint 7, so presumably the Core Stage 3 engine section and boat tail will be in footprint 5 after they are mated. We didn't get any more imagery of the Artemis III Orion service module elements not far away in the operations and checkout building at KSC. European Service Module 3 was delivered there by ESM prime contractor Airbus and the European Space Agency at the beginning of the month, and the word is that Orion prime contractor Lockheed Martin has the crew module adapter ready for mating with ESM-3. NASA KSC Public Affairs told me that the CMA-ESM mate was expected later this month. Hopefully we will get to see images around that operation when it happens. There's still a little more to go over in my interview with Cliff Lanham, the Senior Vehicle Operations Manager for Exploration Ground Systems. I spoke with him on Thursday, August 29th, about Artemis II preparations at the Kennedy Space Center. In the previous videos, I covered the current status of the hardware preparations and validation testing. But I also wanted to ask a little bit about what happens after SLS and the whole Artemis II vehicle is stacked, because there's more work to do after the boosters and the stages and the spacecraft are physically connected. For now, the focus is on putting SLS together, since final assembly of Orion is the critical path and still has a little bit of time and work before it's complete. EGS is planning on a tanking test of SLS next year before final launch preparations, and one of the options is to do that without Orion stacked on top. NASA leadership has not decided whether to do that tanking test with or without Orion yet, but SLS will still be integrated and checked out by itself before Orion is ready to stack. After the boosters, core stage, launch vehicle stage adapter, and interim cryogenic propulsion stage are literally stacked on Mobile Launcher 1 in the VAB, all the operational connections between those elements and others need to be made and checked out. That work is broadly referred to as Integrated Testing and Checkout, or ITCO. Specifically, there are multiple umbilicals that need to be connected from the ML to all of the SLS elements. Most of those umbilicals have several individual connections supported by umbilical plates on the vehicle side and the mobile launcher or ground side. In some of the interviews that we heard when the core stage was offloaded a month ago, I think they were talking about maybe like about a 10-week schedule for the booster stacking, and then the core would be mated after that. How much work, how much of the sort of ITCO work will you need to do after you get the SLS elements mated together?
Yeah, so I mean, you're in the ballpark of the timelines, right? So this fall we'll get into stacking the boosters, and then obviously the core stage, LVSA, ICPS will fall in line with that. But yeah, it's a couple months of work approximately to get the boosters stacked. And then once we get done the stacking operations, we get into a period of time where we'll prep ourselves for the integrated testing that'll then kick off after that point. And then we'll obviously flow through our testing, and at that point, then we get into depending on how the tanking test decisions are made, because those decisions are still to be made. Whether we do a full stack or a short stack. They're to come, and that may drive some changes in some of the testing, but overall the timeline is booster stack the rest of the vehicle, up through the ICPS and then get into integrated testing.
This 2015 era graphic is still useful to illustrate those umbilicals and connections. Since the vehicle is built from the ground up, let's start on the platform or zero deck level. The left and right-hand solid rocket booster aft skirts each have purge and electrical umbilicals connected. The booster's thrust vector control or steering systems are housed there, and those have redundant hydrazine tanks that power redundant hydraulic systems. The aft skirt is enclosed with a thermal curtain, and that enclosure is purged with gaseous nitrogen during hazardous operations like tanking. The aft skirt electrical umbilical connects the ground-based launch release system with the SLS flight computers, which control the last 30 seconds of the launch countdown and are the authority on the launch commit command, which occurs with the Fire to command issued to the SRBs. Once the SRB igniters are fired, the vehicle is going somewhere, and that command is relayed down the boosters to the electrical umbilical into the launch release system to start the umbilical release and retract sequence. The T0 umbilicals and connections from the ground to the vehicle are released, and then the umbilical arms are hydraulically driven away from the vehicle up against the umbilical tower. There are 4 umbilical plate connections to the core stage and a 5th mechanical one. There are 2 side-by-side tail service mast umbilicals that connect to the core stage engine section, a liquid oxygen tail service mast and a liquid hydrogen tail service mast. Those are where the stage is loaded with the cryogenic oxidizer and fuel, among other things. Above, the core stage intertank umbilical, or CSITU, and the core stage forward skirt umbilical, or CSFSU, provide environmental control or air conditioning, a safe vent path for LH2 boil-off, and power and data connections to the avionics. For example, the SLS flight computers for this Block 1 vehicle are located in the forward skirt. The vehicle stabilizer doesn't carry any services to or from the vehicle. It's there to, as the name implies, stabilize the vehicle against wind loads. Above that is the interim cryogenic propulsion stage umbilical, or ICPSU, which provides propellant and other services to the ICPS and air conditioning to the LVSA, since most of the stage is encapsulated inside the adapter. Just in terms of SLS, once those umbilical connections are made, then the launch team can get into that integrated testing and checkout. Once plugged in, the ground launch command and control system powers up the rocket and sees if everything is connected and working correctly. The core stage flight computers are powered up first, and then they are used to power up the rest of the core stage avionics, the RS-25 engine controllers, and the SRB avionics. The ICPS is an independent stage and system, and those avionics are powered up independently of the core stage. The first test, as Mr. Lanham noted, is the interface verification test. After the interface verification test confirms that all the elements are communicating with each other correctly, there will also be some PSETs, or program-specific engineering tests, and I asked about how much of that would be a part of this launch campaign test and checkout flow versus the first one with Artemis I. Doing with SLS after you get the core mated to the boosters and get the ICPS and the LVSA mated, is it just going to be standard checkout this time, or are there still some engineering tests to do?
So there's still what we call the program-specific engineering test. That'll be pretty much every flight. Where there's certain tests where we're going to check out the operation of the systems that are considered higher risk, maybe due to transportation and all, just to make sure those systems are good to go. So we will absolutely be doing that sort of testing, along with IVT, integrated verification testing, where we're looking to make sure, basically the functionality between and connections between elements are all intact. So we will do that, and that a lot of times is like between SLS to EGS, so the flight elements to the ground, flight elements to flight elements, so we'll do all those checkouts as well. So what is really kind of, what I would say is slightly different, right, for Artemis II versus 1 is some of the, like modal testing that we did, the umbilical release and retract testing. We won't be doing that for Artemis II.
The P-sets that check out different subsystems are performed with the whole launch vehicle connected. The launch team orchestrates that from the primary firing room in the Launch Control Center, Firing Room 1, along with support rooms in the building and off-site. As an example, there are P-sets for the core stage main propulsion system, which has pneumatically actuated mechanical systems, and there are P-sets for the thrust vector control system that points the RS-25 engines for steering the vehicle. The TVC system is powered by hydraulics in the stage. The RS-25 engines themselves use both hydraulics and pneumatics provided by the stage, and an engine flight readiness test is conducted as a part of that testing. A tanking test has been on the Artemis II launch campaign schedule for a long time, and there are different types of tanking tests. It's not yet known what type of test will be conducted. NASA leadership may decide to do an SLS-only tanking test, but in a recent story that Stephen Clark wrote for Ars Technica, a wet dress rehearsal was mentioned, so I followed up on that with Mr. Lanham. There's a couple of other things I'd seen from some recent reporting. I think there was a mention that there's a possibility of doing maybe like a full wet dress rehearsal. I don't know if that would be either, it probably wouldn't be with the crew on board, but maybe I'm thinking of the old Apollo days where they used to do like a wet test and then a dry test with the crew, or maybe it was vice versa. Are you looking at doing something like a wet dress rehearsal? Either, I guess it would be after a tanking test, or maybe integrated with the tanking test. But I think it was mentioned that it would be closer to the launch if you did something like that. Is that an option?
Well, I would say it's always an option, right? What I would tell you is that, and again, this is more in Charlie, the launch director arena and how she handles that. But with the results of a tanking test, let's say, and those types of things would probably play into, do we try to plan a wet dress type test into the overall plan? So I think there's still a lot of work to do to see, would that be required? Right now, it's not in the plan to do that. So I think a lot of it depends on how all the processing goes in the tanking test results, and then broader discussions on is something like that really needed.
It's worth pointing out that the original plan for the wet dress rehearsal prior to Artemis I, before all the issues came up with the gaseous nitrogen supply and the hydrogen leaks, included a recycle demonstration that was never performed. The launch team has practiced many recycles as a part of terminal countdown simulations, but performing a recycle from a launch-ready configuration back to a stable point, then proceeding into a second terminal countdown within an hour or so, hasn't been done with a fully fueled flight vehicle under high-fidelity circumstances. But that might not be an objective this time. One of the pictures after the Artemis II LVSA was dropped off in VAB High Bay 4 shows a practice setup for solid rocket booster stacking. We can see an inert center segment connected to a 384 beam and one of the VAB's 325-ton bridge cranes. I'd seen a picture showing that earlier in the summer, and I asked Mr. Lanham where that practice stood at the end of August. On the boosters, I think I'd seen a picture, and I can't remember where I saw it. There was some I guess some practice sessions with some of the inert hardware in High Bay 4, just kind of running through the lift to mate procedures and bringing segments over on a pallet from the rotation building or from the surge building. Is that practice kind of just going to refresher practice going to continue until you get closer, or is that wrapped up?
Yeah, we'll continue. Again, to keep the team sharp, they'll continue to practice the mates and different with the joints on the segments. And what I would tell you is, pretty much the team is all certified at this point, and this is just to keep everybody, refreshed on what the operations will look like, and to make sure they're ready to go when the hardware comes. But that's something we can kind of throttle with the team, depending on what other work may be going on.
So the SLS hardware for Artemis II is either in the VAB, around the corner, or on the Space Coast, with the exception of the adapter that connects SLS and Orion. That Orion stage adapter won't be needed for a while, but the rest of SLS remains ready for stacking, and the team is standing by to find out when that might happen. We got another look at the Artemis II SLS core stage in the VAB when NASA Administrator Bill Nelson visited Kennedy Space Center on August 29th. At the time, he recorded some social media appearances, including a video for his own account. What's interesting in the video short are the quick glimpses of the core stage. We can see a little bit of the open systems tunnel in this pan from the floor of the VAB transfer aisle up towards the ceiling. And a little closer, panning from forward to aft. The cover plates for the systems tunnel will need to be reinstalled before the stage is picked up and moved in the transfer aisle closer to High Bay 3 for stacking, also known as core stage to booster mate. But that operation is still a couple of months away at least. As I noted earlier, we can also see the stage again in the B-roll shot on Monday, September 9th, seen in the background behind the core stage 4 engine section that is being temporarily stored in the VAB transfer aisle this month. Ahead of a U.S. House of Representatives subcommittee hearing on September 10th, SpaceX posted a schedule update on the 5th Starship flight test. Previously, they had stated that the flight hardware, the two-stage prototypes, were ready to fly in early August. However, a significant amount of work on the launch complex and existing launch pad has continued, so the ground hardware is still not ready to support a launch. The Post spends a lot of time on advocacy about regulatory policy, but the update itself was about the estimated completion of the Federal Aviation Administration review of the impact that comes with attempting to return the Super Heavy booster stage to the launch site. That estimated completion date is now late November. Following the hearing and the SpaceX post, NASA Spaceflight and other media outlets got a statement from the FAA which provided a little more detail on the sequence of events and why it will take a couple more months. Interestingly, in the hearing itself, specific dates for estimated completion of the review were publicly disclosed.
I'll look at Starship 5 license approval, which you had initially promised would be issued by September 17th. It then took about a week ago a shift of about 2 months to November 22nd, and then yesterday you shifted the overall readiness date to November 26th. And for this license,
unfortunately, it's not likely that SpaceX or Congress will consistently provide those updates. This was probably a one-off in support of the advocacy. As I've already noted more than once this month marks T-minus 2 years and counting to the Artemis III target launch date, and SpaceX is responsible for completing all the development and pre-positioning of the on-orbit supply chain in less than 2 years. With the 5th test flight slipping until Thanksgiving, maybe on Thanksgiving Day if the license were to drop 2 days before, that further reduces the amount of time SpaceX still has to achieve all the objectives of the tests critical to HLS and to Artemis III. The ship-to-ship propellant transfer demo is baselined as a dual-launch test with multiple weeks in between the launch of the target Starship and the launch of the chaser Starship. The NASA agency baseline commitment calculated at the end of 2023 that completion of the HLS Option A critical design review would be next August 2025. Finishing CDR or a Delta CDR was moved until after the prop transfer demo given past delays. Starship development is very ambitious, and the schedules made public so far have been aspirational, with several delays. The August 2025 CDR projection was coupled with an HLS Artemis III readiness projection in early 2028, but with SpaceX still focused on the higher priority recovery and reusability of the system first, time is running out to complete all the test objectives for that prop transfer demo, finish post-flight analysis, and then finish the Delta CDR activities by next August. Given the uncertainty about the situations with the Orion base heat shield and Starship development in general, it raises the question now whether any big Artemis test flights will be ready to fly in 2025. During this past week, I published a video about the history of the Artemis II mission profile and an early preview of the mission as it is currently known in public. The flip side of that is that with the uncertainty about the Orion base heat shield investigation and its status, there are a couple of alternatives to the current plans to launch Artemis II no earlier than September 2025. One of those options would keep that long-standing risk reduction mission profile, except that this first crewed Orion launch and mission would be delayed to replace the heat shield. The other option discussed would be similar to the choice that NASA just made for the Starliner crewed flight test, which was to take the crew off the return trip home. In the case of Artemis II, the current heat shield on Orion would be flown, but the flight crew would be taken off and the mission flown uncrewed. That second alternate option would have implications for this risk reduction mission profile. Maybe NASA will announce a decision soon, in which case we can focus on the choice. But if not, then in an upcoming video I'll go over those two alternatives. Thanks as always for watching. Click on the like button if you found this video informative. We're about halfway through September now, and it's going to be interesting to see how much more we learn about the Artemis schedule by the end of the month.